Bismillahirrahmanirrahim. Here is Muhammad Farooq, and today we will start our chapter number 1 in linear circuit analysis. Chapter 1 is about only basic concepts regarding our subject, that is about charge, current, and voltage and power. Always pay attention to positive and negative sign of voltages in case of voltages, and pay attention to the direction of currents, because current is a scalar quantity according to physics, but without any direction the current is nothing. Now first we will discuss charge. What is charge? Definition of charge doesn't exist because there are two intrinsic properties of matter, mass and charge. We can only manifestate them, and we cannot define them. So there is a positive and negative charge in physics. Positive charge is due to proton, and negative charge is due to electrons. In our whole circuits, when we will solve all the circuits, then we will observe that we can't create or destroy any charge in the whole circuit. We will only transfer, and this transferring of electron is called current. So what is current? Charges in motion. Charges in motion is called current. Transfer of charge is also current. Transfer of charge from one place to another is observable in our country. The power transmission lines are the medium through which we place our charges from one place to another place. We can write mathematically the current as dq by dt. There are two currents. The currents due to positive charges is important only in transistors, etc. But the current with which we will deal in our circuit analysis will be electronic current, but the convention used for this current will be conventional. Conventional direction will be used in the whole course, that is, it will look like this. This is conventional current. Actually, the electronic current, actually in the circuit, this is the case. But this is electronic current. Conventionally, we will use this current, which will be represented by I, and unit of current is ampere, according to SI system. Unit of current ampere, and represented by A. It can also be represented by this, but this is unofficial. This is also symbol of ampere. We can find current by the equation of charge. We can find charge by the equation of current also, since I is equal to dq by dt. We can find q as dq is equal to I dt, and integrating on both sides we can find charge. Now, types of current. Most commonly there are four types of currents. The first one is DC, direct current, second one is AC, alternating current, and third one is exponential, and fourth one is damping or damped current. Their waveforms are given as, with respect to time, DC current is always constant, is a straight line, horizontal straight line, while AC current is, when we plot this, then it's sinusoidal alternating. And when we plot exponential, this is AC, this is DC. Exponential current, we can draw it as this. Basically, the damped current is a combination of these two currents, exponential and AC currents. This is a combination. If we multiply this signal or this current with this signal, then this will become damped signal or damped current. That is called damped current. And the waveform of damped current will look like this. Now, as I have discussed earlier, that the current without any direction is nothing. So always mention the direction of current in the circuit for correct answers. For example, this is valid representation, and this one is invalid representation. So direction is necessary in each case for DC current. Now let's discuss voltage. What is voltage? Voltage across terminal pair is a measure of work required to move charge through the element. The work required to move charge through any element. For example, this is the element and these are two terminals. Here is the voltage, and this voltage is the amount of work required to push charges into this element. This is called voltage, and other definition is the potential difference between any 2 points is called voltage. The unit of voltage is volt, named after a scientist, Volta. It will be represented by capital V. Sometimes we will represent by volt, the whole expression, but in most of the cases we will only represent by capital V. Let's discuss power. According to physics, power is defined as work done per unit time, and its unit is joule per coulomb. This means that or joule per coulomb or watt, which is represented by W. The power will be 1 watt when 1 joule of work done is required to move a charge of 1 coulomb in 1 second. Means if the expense of energy is 1 joule to move a charge of 1 coulomb in 1 second, then the amount of power required will be 1 watt. This will be simply calculated in electrical circuit analysis by this formula, P is equal to VI. So this can also be defined as the product of voltage and current in linear circuit analysis. Now let's calculate powers in some circuits. For example, here is an arbitrary element and voltage is given, current is also given. Find power absorbed by the element. Since P is equal to VI, and now power P is equal to V, voltage is 2 and current is 3, so this will be 6 watt. 6 watt power will be absorbed by this element as current is entering from positive terminal. Always remember, during solution of any problem, remember these things. If current is entering from positive terminal, then power absorbed will be positive and power delivered by the element will be negative. If current is leaving positive terminal, of any element, then power delivered will be positive and power absorbed will be negative. You can remember this whole concept by simply learning about battery, that battery has these terminals, positive and negative, and current always leaves this terminal, and battery is a supplier, so power supplied will be positive if current leaves the positive terminal of any element, no matters if there is a black box. So note this concept for correct answer in finding power absorbed or power delivered by any element. Now let's take another example. Here is the element. Find power delivered. Find power delivered. P is equal to VI. into -5 is equal to -20 watt. Let's check the direction of current. The current is entering the positive terminal of the element. So the power absorbed will be positive and power delivered will be negative. Our answer will change sign. That power delivered will be 20 watt, positive 20 watt, and power absorbed will be -20 watt. Because actually the element is absorbing power and we have to find the power delivered. So we will discuss now the element, some components of linear circuit analysis, that is types of current or voltage sources in the next lecture. Thank you.